G'day guys, I'm Gordon from Blue Tongue Industries, and today we're going to talk about a filtration system from Ionic Systems, and that is the Zero PBB water quality and purity on the highest level. We're going to go through and discuss the operation of the machine and give you insight on how to use this particular piece of apparatus. Let's give you an understanding on water purity and purification. So purification can be measured in a few different ways, and you may have heard terms as TDS, total dissolved solids, ppm, parts per million, and when you dive into the Ionic Systems range, we move into megohm. So we're measuring the electrical conductivity of the water. What does this mean? If we pull all the particles from the water to produce pure water can also be produced through distillation, steam, but here at Ionic Systems, we use mechanical means to remove those particulates from the water to obtain water quality of the highest purity. So as we travel around Australia and other parts of the world, and in particular here in West Australia, water quality does differ from our garden tap. And we can't do too much about that. All we can do is manage that with filtration systems of an optimal to obtain our pure water. So that TDS, parts per million, as we travel through the many bus depots scattered throughout West Australia, will vary. So when we take a manual TDS reading of our incoming water supply, you'll see TDS levels from 150 all the way up to 500, 600, 700 TDS parts per million. That means that the amount of contaminants in the water on those particular locations is extreme, and our job today is to remove all those contaminants and then put it into practice to clean the exterior of these vehicles. So the application and process we'll go through in detail, and we'll show you how to practically and physically wash a bus. But if you, and I often refer to, if you see a particular car that's being cleaned, and I often refer to a black car, somebody that hasn't cleaned a black car that's full of dirt and film, when the car does dry, one, you'll see brush marks of where that particular individual who's washed that car has missed. But to add to the dilemma, especially here in West Australia, if we don't scrub the outside of that bus totally, we're going to see those dirt marks or brush marks that have been missed. But with the high TDS level and ppm, if we don't filter that water to a part through a filtration system like this, we're going to be left with those minerals and elements drying on the bus, and that's going to leave us with water marks. And if you're a local in Perth and West Australia and other regions around the country with hard water like Adelaide, Brisbane, you'll be familiar with water staining and spotting on car. And through Ionic Systems, pulling all those particulates out of the water, we're going to give the bus and vehicles the optimum shine. Let's now dive into the gauges and indications on this filtration unit. To the left, we have a voltmeter. The voltmeter allows us to determine the condition of the battery, being a 12 volt system, which is deriving the supply of power for pumps, controls and circuitry. So we need to be aware that we need a positive indication of battery voltage on this 12 volt system. So we want to see it above 12 volts. There is an external battery charger at the end of this particular unit, and it is hardwired in that we have a constant voltage supply coming to this particular unit. So look at your battery condition indicator, and let's look for a mark greater than 12 volts, more towards 13 and 14 volts. The hour meter, very, very important. It enables us to determine the amount of water produced by this filtration system, but also enables us to establish maintenance routine tasks in carrying out filter changes as required. So take a note of the hour meter, and that'll be recorded by maintenance personnel on site and maintenance technicians coming to service this filtration unit. The next two switches which we'll see control our hot water. So our Barstow heater, this particular system provides ultra pure hot water to an aid in our cleaning process. Turning the system on, we get a positive green light, and the system will go through a start procedure which will take a few minutes. We have a winter and summer switch. That switch is a 10-degree split switch between winter and summer to give us slightly different temperature variations. When we finish with the system at the end of the cleaning task, we need to ensure that the heater system has been turned off. Let's talk about the zero sequencing controller and the way this filtration system is controlled. It is split down the centre to the left and right. The power button controls power to the two 12-volt pumps which are supplying water to our water-fed poles. So initiating the power with this red push button, we'll get a display on pump 1 and pump 2. Pump 1 and pump 2, pressure and flow can be varied by an upward and downward arrow to give us an indication from 0 to 99 on pump speed. So that will enable flow. In today's world, we're after saving water and having enough water at the brush to adequately clean. So not necessarily do we need to run this at 99, and you as experienced operators will determine how much water is required to save water on the overall cleaning process. So do play with this, vary the speed and vary the flow to give you enough to carry out the particular task. Let's now talk about the fill sequence side of it, which is the right side of the control panel. And I will drop links below this video to other videos that you'll find interesting on the guts of this Ionic Zero PBB system. So the sequencing controller has two buttons, a start and reset. The start sequence controls the fill procedure and will be done when water quantity in the tank does drop. The water storage tanks, where this particular water after being filtered is kept, has a float switch. That float switch will automatically trigger the system off when the float switch is activated and the tank is full. So that needs to be monitored, and depending on the bus location or depot, the quantity of water, whether that sequence or start procedure is started halfway through the day, or if you have very large storage tanks at the end of the day to allow filling of those tanks overnight. But that will need to be managed locally. So when we do go into start, the first light that is indicated is a system purging light. So in this particular scenario, to give you a bit of insight, and you don't really need to have a great grasp on this understanding, but it goes into a sequence countdown. So we're actually flushing the first 3 filters on this particular system. So all the sediment and rubbish that's being captured by the sediment and the carbon filters is dumped overboard rather than pushing it through the filtration system. Let's talk about the hot water system in detail, because if it's not managed correctly, or if you're not competent or know how to use this system, you can induce faults. So it is computer controlled, a single switch operation. When we do flick a switch, we get a positive green light which puts the system into heat. That system does take 5 to 10 minutes to preheat the water. It'll pull diesel from the diesel tank and put it into its integral burner, which will heat a separate glycol tank. So glycol being radiator fluid in a closed loop. Our main aim with the heating system is to preheat the glycol. The noises and sounds that you can hear here are a normal start procedure. We can hear the recirculation of the glycol as it moves throughout the closed loop. Heating the glycol, we keep on one side of a heat exchanger. So we've got hot glycol, hot radiator fluid on a heat exchanger. We have pure water flowing past that heat exchanger, which picks up the heat from the glycol, and that's the way we stop contamination with your pure water, and we get that optimal temperature to enable you to clean faster and quicker. The sound there we can hear is the fuel pump, and the fuel pump going into a start configuration as it starts to draw fuel. As the fuel pump speeds up and as the Webasto fires up, the fuel pump will slow down. These are normal sounds during a start procedure and need to be taken note, and something you'll become familiar with very, very quickly. I just wanted to reiterate, if you have an operator that comes in and flicks the switch on, off, on, off, on, off, it can then turn the system into a fail-safe mode and induce faults. So please be aware, when you initially come in, flick the switch, get a solid green light, which will put the system into start, and away we go. Let's talk about the zero sequencing controller and the way this filtration system is controlled. It is split down the center to left and right. The power button controls power to the two 12-volt pumps which are supplying water to our water-fed poles. So initiating the power with this red push button, we'll get a display on pump 1 and pump 2. Pump 1 and pump 2, pressure and flow can be varied by an upward and downward arrow to give us an indication from 0 to 99 on pump speed. So that will enable flow. In today's world, we're after saving water and having enough water at the brush to adequately clean. So not necessarily do we need to run this at 99, and you as experienced operators will determine how much water is required to save water on the overall cleaning process. So do play with this, vary the speed and vary the flow to give you enough to carry out the particular task. So as we watch the counter count down, all as an automated process, after we finish our system purging, the system will go into flush mode automatically. That is the next stage in the filtration system. At that point in time, you'll notice that the 240 volt pump, which is a booster pump which pushes water through under pressure through the filtration unit, does start up. So the first light, system purging, we have no 240 volt pump and the system is quiet in operation. Flicking over to the system flushing, the 240 volt pump kicks into gear. This system will again count down, flushing those two RO filters. They're a mechanical filter. They're like a toilet roll. Water goes through the filter and around the filter. All the particulates that get caught in the RO membrane are flushed away as a self-cleaning process automatically, and that goes to waste during the automatic fill procedure of this particular system. At any point in time that you wanted to cancel the fill process, we can just hit the reset button at the bottom of the control panel. That will stop the fill sequence and will again start from scratch. When you come in from an overnight fill, or if the tank has hit a full indication, we'll have a tank full light. But why I mention this is, at that point in time too, to start the fill sequence again, you'll also need to hit the reset button. So hitting the reset button after the tank has hit full is needed, or if you needed to stop the fill sequence for some particular reason. So we've just followed the system through the system flushing. We've watched that counter count down. After that process has finished, it'll go into tank fill. And this is the way that we want to hear the machine. Satisfied with incoming water pressure, not cavitating, or we don't have a noisy 240 volt booster pump. So nice and quiet and all systems satisfied. Tank filling will continue until the external float switch in your storage tanks adjacent to your filtration unit hit a full sequence. At that point in time, we'll get a tank full light.
after that tank full light and the water level does drop, to initiate a start or a refill, we'll hit reset and we'll hit start again. At a particular process through the tank filling procedure, we'll get a polish in progress light. That polish in progress light is again an automatic feature you don't have to worry about, and what it's doing is pulling water back out of the storage tanks and re-filtering it through a nuclear grade filter at the end of the process. That will run for 6 to 8 hours automatically, and is again something that we don't have to consider in the operation of a particular system.
Let's now discuss the TDS meter, total dissolved solids, which is a very important part of maintaining this particular filtration unit and knowing the outlet quality of water that the operator is using. So it's only operational during tank filling. If we turn the unit on and the tank is not filling, the data that it's giving us is irrelevant. So do take note, when tank fill on light is illuminated and the system is running, that's when this particular system is fully operational. It has a 2-probe system, an in and out. The in is an indication on the performance on how the RO filters are operating within the particular system. The unit does time out, and when we select the in indication, it actually tells us the water quality coming out of the ROs and into the last filter, or the second last filter, the DI filter. So we're at a very high TDS level here, 600-700 at this particular location. So these two RO filters in parallel are dropping that water from 600 to 700 down to 19 parts per million. When we select out, that is the indication coming out of the filtration unit. So the out gives us the assurance that we have 0 ppm or 0 parts per million TDS going into our water tank, and that is our water that the operators at each individual site will be cleaning with. 0 ppm, 0 parts per million, spot free. So the next few indicators: water temperature, system pressure, and mains pressure. The water temperature, if the system is not running, is an indication of the OAT, our outside temperature. So that water temperature gauge will dramatically rise in 5, 10, 20 minutes after starting our Webasto heaters, which we previously talked about. So when we do go for a start, we'll get a solid green light. After 5 to 10 minutes, when the system is fully operational, we'll get a gradual increase in temperature on the water temperature indicator. System pressure and mains pressure, another two very important gauges. The system pressure gauge is an indication of internal pressure that the system is operating at. All these gauges are set, and it's nice to know information to enable different fault finding techniques, or knowing that the system is not operating as it should be. So the system pressure is an indication that the pump is boosting pressure above our incoming tap pressure, and that'll vary from site to site depending on our inlet flows and pressure. The water coming in will be boosted by our internal pressure pump and give us a pressure reading, which is our system pressure. Our main pressure gauge is one that you'll need to take note. So before you start the machine, you need to know that we have a positive supply on this mains pressure gauge. So that is an indication of the water coming into the suburb, coming in from your garden tap, and allows us to know that the machine does have a water supply before we do hit that start button on the sequencing controller, that we have water that will enable the pump and keep the system operating correctly. System pressure will vary from site to site. Some areas we would expect 40 to 60 psi coming in as main water pressure delivered from our local garden supply. Fuse panels on the end for a bad day, like any electronic component, motor vehicle, fuse panels which look after the 12-volt system and the componentry that makes up this Ionic Zero. So I'll now go through the flow to give you an understanding on how this particular system does filter the water. So we have our mains water supply which is coming in, and that water flow and pressure is set and indicated on our mains pressure gauge. We can't control that, but we need to be sure that we have a positive indication on that gauge before we hit start in a fill sequence. Water comes in, it'll then go into the softening vessel over here and yonder. So that softening vessel will give some good description on how to manage this particular separate filtration unit. So when we are in hard water conditions, like here in WA, having a softener in front of a filtration system, and even some homes or rural properties you may be used to a softening cartridge. That softening cartridge pulls calcium and lime. And calcium and lime in a reverse osmosis system like this tends to block the RO filter. And blocking the RO filter affects performance of those RO membranes, where they do 95 to 98% of the work in this particular unit. So water comes in through the softening membrane, which is rejuvenated at a maintenance procedure through a salt backwash, which is carried out daily or second daily depending on the water operation, and takes a few minutes to rejuvenate that resin in that vessel to allow it full functionality in the next fill sequence. Through the softener into a UV sterilising light on the back of the unit. So the UV light will kill organic growth. From there it'll go into sediment, carbon sediment. 5 micron sediment. Sediment filter, as we know, pulls rocks at a 5 micron level. Carbon filter, two main purposes. It pulls organics and chlorine. Chlorine has an effect on RO membranes, and in a microscopic level can burn holes in that RO membrane. It'll then hit a second sediment filter, again at 5 micron. Following that, it goes into 2 reverse osmosis membranes which sit in parallel. These membranes, discussed previously, are like a toilet roll. Water goes through and water goes around. Water that goes around the filter goes to waste, and water goes through the filter is at this point in time 95 to 98% pure. Moving on to the next process. It'll then go into our final polish mode, which is our DI filter. Deionized resin to drop that ppm level, TDS level, to 0. At a predetermined time, 30 to 45 minutes after a tank fill sequence, we'll get a tank polish. Water will be pulled back out of the storage tank and run through a nuclear grade filter, which is the last process on our filtration system.
So buried in some part of the installation will be a pressure pump. So the primary purpose of that pump is to pull purified water from the storage tank and deliver it to taps located within the wash bay facility. There is a dilemma, and the dilemma is that pressure pump is super thirsty. So we have two main goals at our bus wash locations, and that is to reduce soap usage, and using this highly purified water we can possibly remove about 95% of soaps and surfactants required to clean the buses and enable the bus to dry using the purified water to a spot-free ultimate shine. This pressure pump will supply 1 to 2 taps. So if at that location you connect a pressure cleaning system to speed up the process, you are going to dramatically increase the amount of water usage. So there's an optimal there that needs to be thought about and considered. And if you are connecting a pressure cleaner, perhaps a smaller water usage is in a 9 or 11 litre per minute machine rather than an 18, 20 or 21 litre machine will suffice in saving water on this daily plan to keep those buses glistening.
So, if in doubt, if you're unsure, if you're unaware, talk to your service supervisor. They'll reiterate what we've said here today, and if you need guidance, each depot and site will have literature plastered above the unit, so there'll be contact information for the service representatives, parts and accessories, and that ongoing maintenance support that is needed to keep these systems operating at their optimal. Parts, service, through us back at Blue Tongue Industries. They're here to support. Let's get cleaning buses.
So we've set the machine up, we've dialed up a flow indicator on our pumps, we've come out to the wash bay and we've grabbed our water fed pole. In each wash bay there'll be multiple poles, so if you wanted to run more than one operator, go to the hose reel, grab your Y splitter, grab your hose extension where you can connect from your single point to give multiple operators, 2 operators per side, the ability to wash the exterior of your bus. So we've dialed up the indicator on our flow for each of the 12 volt pumps. And on this particular application, we're only selecting half speed, which is 50. So our aim is to reduce water consumption, and that'll allow us still to have adequate water flow to carry out the external bus cleaning. At each location, you'll have multiple water fed poles. So if you have a single hose reel, at that location, supplied in the kit will be a Y splitter and 2 hose extensions. From here, coming out of your hose reel, we can split into 2 working hoses to allow 2 operators on each side of the bus to clean that bus even quicker. So the water-fed poles are made up of different configurations, and there'll be brushes to suit the different applications. So the Hydra water-fed pole from Ionic Systems comes complete. It'll have an on-off tap which can be placed at different locations in the circuitry, and you may find it fitting at the brush head. Allows you to turn water off. When we do turn water off, the pumps do go into bypass, so at the end of the day, remember to dial the pumps back down to 0 and hit the off button on the left side of the sequence controller to turn those pumps off so they don't run 24/7. Various brush heads, different applications, flocked and non-flocked. You'll have, and it comes down to personal preference, pencil jets, which is 4 single jets, or fan jet arrangements. So that is a personal preference in the way you rinse and clean. The Hydra water-fed pole has adjustable clamps, 17 foot in reach, and we're able to extend each particular section, being careful not to over tight the clamp section. And that'll hold the sections in place to enable you, the operator, to keep your feet firmly on the ground and reach heights at the top of the bus during the cleaning process. So let's now talk about the cleaning process. And earlier on in the video we did discuss that black car, and if we have seen that black car driving around where the kids might have cleaned it, or we might have been in a rush to wash it, when that does dry, you can see if you're using a brush or chamois where you've actually missed. So it's very important that we scrub the entirety of the bus, and the speed at which you do that, if you're using the ThermoPure, so the ultra pure hot water, or even if you're using the cold water from this system, will enable you to work and establish a speed and rinse technique that will give you the optimal spot-free finish on your fleet of buses. So in the cleaning technique, and we're all affected with gravity, so we need to allow for that. So we always need to start high and finish low. So you wouldn't start cleaning and rinsing at the bottom of the bus, because when you do the top, the dirty water will run over that clean area that you've already done. So having ultra pure water. Water is not water. When we remove all the contaminants and purify it to a level with the Ionic System 0, we obtain a purity that's not seen before. An Ionic system set this in 1997. So water doesn't behave the way it normally does. Under a microscopic level, it starts to pull dirt back into it. So when we agitate and loosen the dirt and then rinse, it pulls the dirt back in. The rinse power will wash away the dirty water. So there's different types of surfaces, hydrophilic and hydrophobic, and depending on what you're going to have, whether the water will sheet or whether it will bead. In a perfect environment, if you were detailing an extremely high-end vehicle and you are washing, you need to treat that each one of those beads of water could have dust in it. And if that dust or dirt does dry that we've removed from the bus or vehicle, it will dry with a watermark. So the tools of trade will be optimal when we agitate and rinse, and it will dry 100% spot free. So if you can obtain that technique and with speed and precision.
Good morning, I'm Brad from O'Brien Electrical Greenwood. This is a zero bus washing system. I'm going to show you how to backwash the softener, okay, which is important because the softener protects our two RO filters, which are quite expensive. They take all the lime and calcium out of the water, and that's what stops the buses from getting streaks on the windows. Okay, so we need to first turn off the unit, which is our little red button. Okay, and we turn off A and B taps. We turn on C and D, which goes to the drain. And then we turn our water on to the canister, which has got 2 fingers of salt in it, which comes out of the bucket. So when you put your canister together, when you're putting the salt in, just make sure there's no salt around the top edge, and then when you tighten it up, it won't leak. So we run that for about 10 or 15 minutes, and what that's doing is regenerating the softener, like I said, protecting the RO filters. And it's as simple as that. Run it for 10 or 15 minutes, then come back in and do the reverse. Turn off the water, turn off C and D, then turn on A and B. Now the water is coming straight through the softener and going into the